Okay, the transport layer receives the segment from the network layer just below. So the transport layer has the responsibility of delivering a data in these segments to the appropriate application process running on the host. So the process can have one or more sockets, those through which the data passes from the network to the process and through which the data passes from the process to the network. Okay, so the transport layer in the receiving host does not actually deliver the data directly to the process, but instead to an intermediate socket. Because at any given time, there can be more than one socket in the receiving host, each socket has unique identifier. So each transport layer segment has a set of fields in the segment to help receiver to deliver the data to appropriate process socket. At the receiving end, the transport layer examines these fields to identify the receiving socket and then direct the segment to that socket. So this job of delivering the data in the transport layer segment to the current socket is called demultiplexing. The job of gathering the data chunk at the source host from the different socket, encapsulating each of the data chunk with the header information to create the segment and passing the segment through the network layer is called multiplexing. Okay, you can see from the diagram. Okay, you can see the segments. These are all the segments, and P1, P2, P3, P4, all the processes. So first transport layer multiplexing requires the sockets have a unique identifier. Second, that each segment have a special field that indicates socket to which the segment is to be delivered. These special fields are the source port field and destination port field. Okay. See, in this example, we can see the process P1, P2, P3 and P4. P3 is, assume P3 is the sending side and P4 is the receiving side. Now, the segment is passes through the network layer and then via P1, P2 and then via this one. So this is an example of multiplexing and demultiplexing. So in the sender side, there will be an encapsulation, and the receiver side, there will be a decapsulation of the thing. So now how it is going to work is, as I mentioned, there will be two parts. One is the socket will have unique identifiers, as well as the segment will have special ports. One is source port number, another one is destination port field. So here you can see 32-bit, one is source port field, another one is destination port field. So the port is a 16-bit number which is ranging from 0 to 65,535. So the port number is from 0 to 1024. That is a well-known port, and it is restricted, means it is reserved. Okay, for well-known applications such as HTTP. For example, HTTP, as I mentioned in the previous slides, the port number is 80. For FTP, that is file transfer protocol, in the application layer, whatever we have discussed, the port number is reserved. That is 21. It is like that. So the UDP, which is going to perform connectionless multiplexing and demultiplexing, but the TCP will perform connection oriented multiplexing and demultiplexing. Now we will see first the connectionless transport, that is UDP. So UDP is a connectionless protocol which performs only multiplexing and demultiplexing functions or some light error checking. So it takes the message from the application process, attach the source and destination port number fields for multiplexing and demultiplexing services, add two other small fields, and then passes the resulting segment to the networking layer. See here. So it is a creating packet, and then you are going to send it to the next network layer. Next layer. For creating packet, we have used the statement datagram segment. So my socket one is a packet name. Socket name is equal to new. You're creating so new keyword with the datagram socket with 1, 2, 3, 4, 5. Now, after doing this, creating a packet means you're appending with IP address as well as destination port number, right? And after that, the network layer encapsulate the transport layer segment into an IP address. So you have appended with the destination port number also, destination IP address also. Correct? And then make it a best effort attempt to deliver the segment to the receiving host. If the segment arrives in the receiving host, UDP uses the destination port number to deliver the segment data to the correct application process. Okay, then it will use the destination port number. Okay, in order to deliver it to the correct application process. So, many of the applications are best suited for UDP for the following reasons. First reason is finer application level control over what data is sent and when. So under UDP, as soon as the application process passes the data to the UDP, it will package the data inside the UDP segment and immediately pass the segment to the network layer. TCP on the other hand has a congestion control mechanism, right? That throttles the transport layer TCP sender when one or more link between the source and destination host become excessively congested. The TCP will also continue to resend the segment until the receipt of the segment has been acknowledged by the destination. Since in the real-time scenario requires a minimum sending rate, do not want to overlay delay segment transmission, can tolerate some of the data loss. TCP service model is not particularly well matched to the application needs. That time we'll go with the UDP. Second is, it is a no connection establishment. TCP uses three-way handshake to establish a connection before it starts to transfer the data. UDP just send the data without any formal preliminaries. So UDP does not introduce any delay to establish a connection. Third is no connection state. TCP maintain a connection state in the end systems. This state includes receive and send buffers, congestion control parameters, sequence numbers, acknowledgement number, all parameters. UDP on the other hand does not maintain any connection state and does not track any of these parameters. For this reason, server devoted to a particular application can typically support many more active clients when the applications run over the UDP rather than the TCP. Okay, so and last important feature is small packet overhead, header overhead. TCP segment has 20 bytes header overhead in every segment, whereas UDP has only 8 byte overhead. So that's why we will go with the UDP. So next we will start with UDP segment structure. Okay. Not your own.